Hirba is a research programming environment exploring legible live programming through rich, in-context representations. Let's look at what this means step by step. Legibility is the motivating principle of this project, and Wikipedia defines it as the ease at which a reader can decode symbols. I will stretch this definition into interpretability. How easily can you visually make sense of something? So, for example, how does this list of coordinates fare? Can you make sense of them? How easy was that? Are the coordinates valid? And where are they? Now, how would your answers change given a map of those same coordinates? If you are a geographer and or from northern Germany, this exact image might have already formed in your head. But for the other 8 billion people on our planet, raw coordinates are rather inscrutable. The next example is of path commands within a SVG element. The question is again, can you easily make sense of it? Do you have an image in your mind of what the resulting shape is? Does it match this one? Again, if you are a vector graphic aficionado, your mental image might match, but that interpretive skill is not common. This last example is from an application I built for checking whether one's rent is within the legal limit in Berlin. The legal regulation contains a table which we had to hardcode into this nested data structure. Now, if you are used to JSON, which most programmers are, you can fairly quickly find specific cells. And even whole columns can be read from the code, top to bottom, since this is how we chose to encode the table. The other dimension, however, is lost. Rows cannot be easily identified, and reading row neighboring cells requires jumping and scrolling through the whole JSON. Classical textual programming is always transparent. What you see is what you get, and also what the compiler gets. But it might not be what you understand. The chosen literal representation of data can be illegible to many people. Still, there is an upside worth keeping in mind. The transparency of textual code means that no information is hidden. So, barring compiler bugs, quantum flips, etc., all bugs in a textual program can be found by reading the code. Hirba aims to retain this quality. This is what creating a variable assignment looks like in Hirba. Initializing the name variable with an empty string. Variables are reactive bindings, which we can, for example, use to bind them to an input field. By pressing play, we can see how using the input changes the runtime value of the name variable. The simplicity of binding a variable to an input is inspired by the popular React descendant library Svelte. An essential building block for Hirba is the box type, which composes view elements. The view config panel adjusts different properties, serving a live preview while changing parameters, like the inputs border and padding, or the box's axis and gap between items. These kinds of controls may in the future alleviate the need for design tools like Figma and make designing within the programming environment feasible. The panel also betrays my future ambition of making all property changes accessible to the keyboard, as can be seen by the bold characters. Another inspiration is the web development trend towards utility CSS, using shorthands for setting style properties, which has been popularized by Tailwind. This is what the equivalent UI definition looks like in it. Hirba has similar shorthands without having to rely on a string-based DSL, nor its at times cryptic naming. This also aligns with our prior goal of keeping everything transparent at the right level of information density. The set of available UI elements can be extended with a JavaScript bridge. An example is this map element. Hirba is a structured code editor. Keyboard navigation does not work through a caret like in text editors, but by finding the next hitbox in the direction pressed. This seems more appropriate for supporting UI elements for which character counting is not an option. My prior work has been focused on higher-level keyword commands in structured code editors, which makes me confident in the approach without having laid it out more fully in this environment yet. My notes on that can be found in this URL. Other sources of hope for structured editing are the work around Hazel and Tyler, which tackle the issue of missing flexibility or fluidity compared to text editors. Now bear with me while I explore an idea that is not implemented yet. This is a mock-up of a simple application that collects the coordinates of where a user clicked in a points of interest variable named poise. It is initialized with an empty list shown as a crossed-out box. The list fills up as I click around the map. Since all elements in the list are of the same type with the same fields, it is shown as a table. Going back to the initial example, is this legible? Not for many people, so a different representation might be more appropriate. By opening the view config panel of the table, a different view can be chosen or created, as I do here. This new view declares itself for a specific type, in this case a list of coordinates, which automatically uses the previously collected list as example data, since this was the context from which the view was created. The actual definition of this new view is rather simple, since the map element already comes with a markers property. By also including a coordinates index in the list as the title of the marker, the new view also retains this bit of information. There could still be cases of hidden information, for example with overlapping markers, depending on how our map element handles these. I'm glossing over this for now, but it is the type of question one should ask oneself when building a new view over data. Another aspect worth pondering are views that mutate. It is an open question for hirba whether these kinds of view definitions should explicitly state that they can also receive a binding to their respective types, or whether that is implicit. If it is implicit, this view could be understood as one that also allows dragging around the markers on the map to mutate the underlying coordinates. Now back to our original application. The new data representation is being used, and changes to the points of interest would show up on this little map. This is what legible live programming through rich in-context representations means. While I think these initial findings are very promising, there are still several areas that require more experimentation. Clearly, nesting rectangles within a flex layout is not the lowest level of abstraction for UI development. Hence, things like absolute layouts or direct draw do not benefit as directly from this kind of editor. This is why elements like maps need to be imported. I have some ideas for absolute layouts, but they will not generalize to other problem areas like rich text editors. There's also the question of visualizing structs that contain free variables. All the examples in this presentation only had concrete values. How visualizations should behave with free variables depends. A table, just like a list, could simply contain the variables in its cells. A map or a SVG path could do something more advanced by showing a line for a point with a free variable. And then there are problems which are best stated purely symbolically in text. Another open question: code formatters have become a standard tool in modern programming practices. How would a formatter work in this environment? With a code containing visual elements, it might be more apt to think about a layouter of sorts. This is the end of my little demo. Thank you for listening.